Falling into a black hole is terrifying. But what if I told you falling into a neutron star might be worse? It's not a clean death, it's a brutal unraveling, atom by atom, until you're nothing but cosmic spaghetti. Welcome to Parallel Paradigm, where space gets strange, fast. Let's rewind. When a massive star dies in a supernova explosion, its core collapses. But instead of forming a black hole, sometimes it becomes something just as bizarre, a neutron star. Imagine the mass of the sun squeezed into something just 12 miles wide. That's like cramming Mount Everest into a single grain of sand, only with way more attitude. Its density is so extreme that atoms collapse. Protons and electrons merge into neutrons. What's left is essentially a giant atomic nucleus suspended in space. Now imagine you're drifting toward one. There's no atmosphere to warn you. No swirling gas like a black hole, just a silent glowing sphere. But gravity is already at work. As you fall closer, the gravitational pull on your feet is thousands, millions of times stronger than on your head. This differential is what physicists call tidal forces, and in the case of neutron stars, they're strong enough to rip molecules apart. You wouldn't just be stretched, you'd be shredded. So, what actually happens? As the tidal forces ramp up, your body begins to elongate. First your limbs, then your spine, then down to your atoms. Your body becomes a chain of particles, a spaghetti strand of atoms, pulled longer and thinner as the gravity gradient stretches you vertically and compresses you sideways. This horrifying process is called spaghettification, and it's not just theoretical. We've seen this happen to stars being devoured by black holes. Now imagine it happening to you. But unlike a black hole, a neutron star doesn't have an event horizon. It has a surface, a very hard one. If, somehow, you survive the spaghettification long enough, you'll slam into that crust at a third of the speed of light. That's like crashing into steel at 1,000 times terminal velocity. The result? You wouldn't leave a crater, you'd leave quarks. Your body would vaporize into subatomic particles instantly. Let's talk about what you're falling into. The surface of a neutron star is solid nuclear matter, the densest material in the universe outside a black hole. Underneath is a bizarre soup of superfluid neutrons. This liquid can flow with zero viscosity, meaning it never slows down. It also spins fast. Some neutron stars, called pulsars, rotate hundreds of times per second, faster than a kitchen blender. Oh, and their magnetic fields, 1 trillion times stronger than Earth's, strong enough to distort atoms and erase your credit card data. From orbit, just to be clear, a black hole swallows you silently. A white dwarf might roast you slowly. But a neutron star, it destroys you loud, hard, and weird. It bends physics to its will while you scream silently into a vacuum. It's the kind of death where even your atoms don't walk away intact. So next time you gaze up at the stars, remember that some of them are neutron stars. Cosmic death marbles just floating out there, waiting for anything foolish enough to get too close. If you fall in, you won't just die. You'll become one with the weirdest matter in the known universe. This is Parallel Paradigm. Subscribe to see what else the universe is hiding. And remember, some stars don't burn, they crush.